Again, welcome to CS280 class, Programming Language Concepts. These lectures cover the course outline. Our main objective for this course is to understand the concept of programming languages, also become familiar with different language paradigms and the kind of problems they are for. We're also going to learn the features and also differences of some of the widely used languages, such as C++, Java, C#. Those are the imperative languages. And also we'll discuss about Scheme, Lisp, Haskell, which are the, again, functional languages. Also, we're going to discuss about Prolog. So we have a first question. For example, given two programming languages, how do they differ in expressing the same algorithm? So these are some of the questions we are going to face in this course. Also, which programming language is better? And also how to evaluate goodness of programming languages. In our course textbook, chapter 1, we are going to discuss about the criteria we normally use to evaluate a programming language, such as reliability, robustness, writability, etc. Again, we're going to discuss that in details. Also, why are there so many different programming languages? What is a programming language anyway? Actually, that will be our first discussion. We shall go through the definition and the purpose of programming language. Also, why does a programming language have so many different features? Some programming language have some features, others may have different features, and we shall discuss so. Also, we are going to discuss the features that are implemented. Especially, we are going to focus on object-oriented programming, the concept of encapsulation, polymorphism, inheritance, also abstractions, etc. So that's the topics of this course. Now, as we said, the main programming language categories we are going to focus in this course will be functional programming, imperative programming, event-based programming, also logic programming, and visual programming, which in our textbook, we will break it into 3 sections. That's functional programming, imperative programming, and logic programming. Now, event-based programming and visual programming will be also imperative language or programming language. So what is a programming language anyway? Here we say in a vocabulary, also set of grammar rules and associated meanings for communication between people and computers, or communication between computers. Now, so a programming language can be the same as, let's say, English language or French. We may have some vocabularies. We may have some rules we have to follow, especially grammatical rules. Normally in programming language, we call that the syntax. That's the grammatical rules. And also the associated meanings. In this case, will be semantics. So programming language consists of syntax and also the semantics, the meaning. And the goal of an English language or French is a communication between two people. Now, programming language, as we said, can be a communication between people in the computer or between computers. So another definition we have here, which is more technical definition, is a programming language is a notational system for describing computation in machine readable and also human readable. And this, again, definition came from K. Loudon. He's a professor of computer science at San Jose State University. So why we study PLC, or why we say PLC is more important? Again, PLC stands for our course, which is Programming Language Concepts. Now, first, a language is a framework for problem solving. So it may facilitate our thoughts and also the ability to solve problems. It may also help us to make fewer mistakes. So example, we have a C language that supports only static and global variables. For example, no malloc. So how do we choose the programming language? Most of the time, we're going to choose a programming language based on our problem that we want to solve. And also, if it's a business organization, then most likely it to be based on also the business decision. So for example, if a company is using Java, and that's most language they use to, again, develop their systems and their programmers, most likely they don't want to train or send another employee to go and learn different language, and then they use it in the course, in the process of, again, developing their system. So what we're trying to say is that, again, decision of what programming language we use, especially in business organization, I think economics also may play part in terms of training employees to, again, in a specific language. Also, it may depend on the problem that we want to solve. For example, a machine learning problem, we may use Python because Python have a lot of almost all the machine learning algorithm packages than to use C++ language. So again, depends. And these are the things we are going to discuss in this course. So next is the expressiveness also. So factors influence programming language, expressiveness in terms of application domain, programming methods, multi-programming, interactive system, etc. Also implementation in terms of efficiency, the computer architecture, operating system, toolchain, libraries, etc. And every convenience has its cost. Must recognize cost of presenting an abstract view of machine. So we should understand the trade-off in programming language design. Also, PLS, or the programming language as a PLC, programming language concept as a course. What is not? And so this is what always the first day of the class, I will let all of us to know. For example, we are going to cover almost 20 different languages. There's no way we can learn 20 programming language in one semester. So this course do not teach you a programming language. We are not going to learn a programming language. Also, do not teach you how to program. So this course is not a programming language, but what it is that it introduces the fundamental concept of programming language. Mostly, we are going to focus on the features of different types of programming language. We are going to analyze the advantage, disadvantage between two or more different programming language. Should I use imperative language or functional language or logic language based on the problem, and etc. One simple rules we know is that writing a code, if I can solve a problem with only 2 lines of code, I prefer than to have 10 lines of code to solve the same problem. So the lesser the code, we use our computer resources very, very manageable. When I say computer resources, I mean the memory and also the CPU time, how long it takes to execute. The bigger the program or the code, the longer the code, the more time it will take the CPU to execute it. And also we may need more space, the memory space, to store it. So yeah, we're going to also discuss design issues of various language constructs. Also examine the design implementation choices for these constructs. We're also going to compare the design alternatives. And also we need to be familiar in at least one programming language in order, that's the prerequisite. So fortunately in this course, our prerequisite is Java programming language. Normally before students take a Java programming language in our school, they should have taken Python. Also Python is CS 101, then CS 102 is Java. So we should have at least 2 programming language knowledge before we start this course. So why study PLC again, programming language concept? Here is to improve our ability to develop effective algorithms and also to use our language. For example, we may understand more details about the concept of object-oriented features, recursions, call by value, call by reference, also to allow a better choice of programming language. Also to increase the ability to learn new languages, possible to develop your own language also. Also to make it easier to design a new language, to understand significance of implementation. Example would be the efficiency of a recursive function. Should I use recursive function or use a loop? And as we know, using recursive, we need the overhead of computer, especially the memory resources, because the function have to keep calling itself over and over. Using a loop is more faster, less overhead costs. But maybe we may have some problem, and using a loop will be difficult to design, but recursive will be easy to design. So again, these are the few things we're going to discuss. Now, the course information, again, we shall go through the course syllabus. So again, see the course syllabus. As we said, the prerequisite for this course is CS 102. Also, if you have a data structure and algorithm design course, which is a CS 335, then you are good to go. So this is our textbook for this course, Concept of Programming Language by Robert Sebesta. We are using the 11th edition, published by Addison Wesley. And these are the topic we are going to focus on. The textbook have somewhere around 16 chapters. We shall do our best to cover as much as we can, but from the previous semester, we normally cover up to around 12 chapters. Yeah. So the main thing, for example, chapter 16 is logic programming language. Surely we are going to cover chapter 16. Chapter 15 is functional programming language. Surely we are going to cover it. So we are going to skip some few chapters, or we don't go detail so that we have enough time. Also describing syntax and semantics. This chapter, sometimes we don't cover it much, but the names, bindings, and scopes, variables, different data types, such as array, stack, int. Also expressions and assignment, control structures, subprogramming, object-oriented programming, abstract data type or ADT, encapsulation, inheritance, concurrency, exception handling, and event handling. So these are the general topic for this course. And also, again, our textbook have all these topics. Now, expected workload, we have assignment. So we should expect one assignment every 2 weeks. Some of the assignment will be programming assignment also, and some of them will be theory. The grade breakdown, as we said, we are going to have 5 assignments for the whole semester, which is 150 points. So it will be 50% of your final grade. Also, we have 6 tests, or I may call it quiz. This will be a short test, 10 to 20 questions. And that will be 30% of our final grade. So which means each test is 50 points. Also, we have a midterm exam, which is 250 points, 25% of the final grade. Final exams also is 25% of the final grade. And class participation is 5%. Also, this information is in our syllabus. Now, generation of computer languages. We know we started with the machine language, then we moved to assembly language, then high-level procedure, and also 4G. Now, 4th generation language is a program-specific language. For example, SQL. SQL is basically designed for manipulating a database system. Now, we know machine language is more better for the computer. That's the language the computer understands, zeros and ones, binary. But as a human being, to write a code in machine language, it takes time. This case means we are writing. That's the beginning of programming language, where we don't have no operating system. And so you write a code that, again, directly will interact with the computer hardware. So along the way, assembly language came. which also is possible to access mostly the registers, special memory in the system. But we have something called assembler, which will convert the assembly language to machine language in order for the computer to understand. Now, assembly language is kind of a little bit easy for us. That's why, again, so was developed. That moved us to the high-level language, which is now almost anybody can program, because writing a programming language is like writing an English code. But the thing is that we need something, a software that can either translate or compile it to a machine language, translate so that, because again, we know computer understand only 0 ones. With assembly language, we need assembler. Normal assembly language have something called a mnemonics. Mnemonics is the command we use. For example, I can say add or move or store, but computer don't understand the meaning of store. So we have assembler that will convert it to 0 ones. Same thing applies to high-level language such as C, C++, Java. We may have other compiler or interpreter that at the end to may convert to 0 ones machine language. So let's go through each one. Machine language, we said these simple binary instructions are called machine language instruction. So normally machine language will look at what we have. Binary instruction means 0, 1, 0, 1. And this is the language the computer understands. Now, for a human being to write a code in machine language, as we said earlier, it takes time and very difficult. So next, we had assembly language. So we can see assembly language here looks a little bit familiar to us. We are seeing English alphabet. So MOV means to move. And we may have AX, maybe it would be a register name or accumulator, etc., or a constant or variable. Pop means again remove, etc. So we need assembler that will convert this language. We can see the assembler will convert the assembly language to machine language. So we say simple assembly language instruction have a one-to-one translation to machine language. So a program called assembler convert assembly language into machine language. Next, we have the higher level language. This is where it gets more easy for us to write code, normally called the third generation language, because it's English-like syntax. Also, descriptive names to represent data elements. Maybe I want to store data in a variable and the data is salary. I can name the variable salary in English. Also, concise representation of complex logic, and also use of standard mathematics symbols. So example given here, total equal to quantity times price times 1 plus tax rate. Now, total, quantity, price, and tax rate will be a variable, which that variable is a memory location. Now, this is where it gets very nice for us. We have operating system now. So when we declare variable, the operating system will randomly allocate a memory space for us. We don't need to know the memory address where it is. But previous program like C, C++, we have pointers that we can use to retrieve the address of the location. Java also has another means of making it possible to get the address. But again, we don't really need it much. We also have something like a conditional execution or looping. So most programming language, we have sequential structure. We have something called a control structure. So we start with a sequential control structure, which tells us that execution will start from up, down. So it's a built-in up, down. We cannot change the flow of the control unless if we have a condition. So if I have a condition that if the total is greater than 0, then move to step 2. If it's false, move to step 5. Now we are changing the control based on the condition. So condition will be the selection control structure. Then looping, if we want to do something over and over again. For example, I want to find the sum of numbers from 1 to 2000. I don't want to write 1 plus 2 plus 3 up to 2000. So I may write a loop to execute 2000 times. and I write only one code to add the values. So also we have a functional unit, such as functions or classes. In the future, we may discuss this. So as we said, programming is faster and easier. That's for the high-level language benefits. Everything almost in English. Also, abstraction helps programmer think at a higher level. So the concept of abstraction is that we don't care about the detail, just more abstract level. Then also standardized language enable code to be machine independent and reduce training effort. Also, complex programs can be divided into smaller programs, each coded and tested separately. Also, code reuse. For example, inheritance gives us that concept also, or functions also. Also provides standard program interface for hardware interaction, such as input and output. So all this we mentioned is have all the features in high-level languages, C, C++, Java, etc. So these are some of the high-level languages in terms of imperative. Fortran, these are the earlier languages, COBOL, BASIC, C, Pascal. Functional language, we have the Scheme, Lisp, Haskell, F#, etc. Then logic language, in this course, we are going to focus on only Prolog. But there are a couple of them, for example, Crisp. And normally logic language in the earlier time normally is used to develop expert systems. Also, we talk about object-oriented, such as Java, Python, C++, Perl, etc. Now, the fourth generation language, as we said earlier, languages that focus on specific application, such as SQL, structured query language, is fully databases. Then we have the PostScript, page description language for printers, HTML, PHP for World Wide Web websites. Then we also have Mathematica for symbolic math on computer. Now, our course and also the textbook doesn't focus much on the fourth generation language. As we said, we are more going to focus on functional and also imperative and also logic programming language. So what are the factors that influence languages? Here we say we have many factors. One is the environment, the capability of the machine that we are communicating with. So earlier computers have a few instructions because those computers don't have no operating system. And also there's no good memory management system. And even the memory was very small. Now, application domain language is influenced by the kind of information we want to communicate. And also, I would say the type of problem we want to solve. So, for example, if I want to solve AI problem in a very quick way developing a rapid system, maybe I may use a functional language instead of imperative language. Again, depends. So these are the program language paradigms we said. We have the imperative. Normally the features, again, in the future lectures, we will go details, but the features of imperative language, number one, variable represent data in a memory location. So we can update the variable content because we consider variable as a memory location. Also, it has a loops. We have assignment. Assignment is different from equal sign. So for example, in functional programming language, a variable is a value like college algebra. When we say variable, it's a value that can change. So in this case, we cannot update the content. So that's why in functional language, we don't have no loops. We have to use recursion if we want to do something over. Imperative language, we still have recursion, but we also have loop. There's nothing like assignment operator in functional languages because we assign assignment here. We say we assign a value to a variable. It's not equal, just we assign it to it. And since functional language, we don't have no variable, when we use the assignment operator, it means equal. We are giving it some. So example of, again, the language also we gave Argo, C, Pascal, Ada, Fortran. So all these are imperative language, including C++, Python, C#, etc. So functional language, normally the keyword is here. It considers functions as a first-class entities. Actually, in functional language, we can have a function as an argument or a nested function, and also can be used same as other forms of data. All execution is by function evaluation. So it's characterized by recursion and also functions as a data. Execution on values, not memory location. So a variable, there's nothing like a variable. So you have to say variables are not necessary. Variable is a value, same as computer, college algebra. Also, a function can dynamically define and return a new function. So it's a self-evolving code. And also, logic program is focused on declarative. It specifies what must be true, but not how to compute it. So which means we have to have the logic inference, the basic control. There's no sequential operation. Non-deterministic may have many solutions or none. We may cover this again in chapter 16. Functional again is chapter 15. Then we may discuss object-oriented concept, which is an object containing its own state, and also function that operate on that state. So here we may have something called the class. A class can represent an entity, for example, student, vehicle, any table, any entity. Let's say a student now. Now we say a state data. So a student in this case will be the characteristics or the attribute will be the student ID, last name, first name, address. And the function will be the behavior of the student. So for example, we can calculate the student GPA. Student can take a test, or student is late, how many times is late. All this will be, in Java, we may call this the methods. So program logic is instantiation of object. When we say instantiation of object means we are creating object from a class. And we may discuss this more detail in the future. The concept of encapsulation, protection, etc. So example of object-oriented programming can be C++, C#, Java, Python, Smalltalk. Also, we have the declarative, which, as we said earlier, state what needs computing, not how to compute it. So example would be the logic programming concept also. And here also we have the SQ, like the fourth generation language, SQL, mathematics also share the same property. Prolog is also a declarative, as we said. SQL, we can write a query that selects all employees from New York, where they are, where condition is, and they are from New York, and the condition is that they earn more than $50,000 a year. So you send this query to the system. If you meet the criteria, we get the result of the employees. So the background we need here, first we say, what is a good programming language design? What criteria should be used to judge a language? How should success or failure of a language be defined? We will also define language as a successful if it satisfies any or all of the criteria. For example, we have a language, it achieved the goal of its designers. Also, it attains widespread use in application area. Example would be Python or Java, very successful language. Also, it serves as a model for other languages that are successful. And that will be the end of this lecture. So again, these lectures, we discuss it by the course outline, why we need to take this course, and what we are expecting in this course. Now, I'm going to wait for a few seconds if any question. Okay, so again, we see in the next lectures. Thank you.